A pair of smart little LED lights that come in equally smart packaging. Car door warning light. I would like to show you the listing these came from. Unfortunately, it's another of these listings that has mysteriously been taken down, suggesting to me that HMRC, the Revenue and Customs, are targeting even British-based Chinese sellers. So these ones were shipped, as far as I can see, within the UK. And in the package, you get two of the little LED lights. You get some sticky pads, which have an M printed in them. I think that's supposed to imply sort of 3M adhesive, except it's only 1M, so therefore it's 1M adhesive. And a little instruction manual. Let's see if I can get this out. An instruction manual with text so small that even the magnifying glass is quite hard to read. Oh, it's in Chinglish. When fixed, the sharp angle is upward, and the sharp angle is the position of the magnetic induction switch. Okay, I'm not sure what it means by. Oh, right, okay. There is a little point in this, I didn't notice that. I don't know if that's for any particular orientation. Does it really matter? The magnet will trigger it from all directions, although it's most sensitive to the position of the sensor, which I can see inside. I should cut to the chase, shouldn't I? I should open this up. I should open it up and whip the circuit board out. Did I explain what these were for? They're for car doors, so if you don't open them into the path of, well, if you open the door, it kind of indicates to oncoming traffic that the door is open by flashing the sort of hazard warning light. And initially when I saw them, I thought, well, that's actually quite big. You know, it looks quite large, because the idea is that it's mounted in the sort of the edge of the door where it closes into the frame. But on looking at a Skoda Fabia that was conveniently located, I noticed that there were a couple of places it could actually put, that there is tons of room in the lip of the door door where it meets the frame. So I've already taken a picture of one of these, so we can actually take a close look at it, because it is rather tiny. And here's what the circuit board looks like. Pen. We have the ubiquitous little 8-pin chip, and this could be a PADUC because it has the correct sort of pin out for that. It's got the positive going to pin 1, it's got the negative going to pin 8. That's going through in a plated through hole here. We have this mysterious 6207, which I know is a Hall effect device, but I didn't immediately find one by typing Hall effect 6207, it didn't come up. And then we have 27027 and a 0 multiplier, so 27 ohms. We have one LED in series with a resistor connected to each pin of the microcontroller. I'm guessing they've done that to allow that microcontroller to drive a lot more LEDs. They all just seem to flash together. They don't do any patterns, although technically speaking, with one per pin in the software you could, and fundamentally that is it. I do notice a couple of other pads down here. I have a sneaky feeling that they're designed for an external, well, this is connected to the, I don't know if it's going to be pull up or pull down. The Hall effect sensor has got a positive connection, it's got a negative connection, the output. It seems to be going straight to a chip pin, so they may be using internal pull up or pull down. I suppose there's one way to find out. That's to open one of these. I've already got one open, so I could use that one. Let's stick the magnet back in that one. So if I get a meter, and we zoom back out again a little bit, and I stick this to, say for instance, volts, I should be able to probe from the negative connection, which I think is here, onto that contact. So that is pulling low, and if I remove the magnet now, it should go up to about 3 volts. Ish. Yeah, around about that. Yeah. So to activate, it goes into a different flashing mode. It seems to save battery. If it's left open too long, it goes into that mode. So to activate, it's going positive, but when the magnet's there, it's pulling that down. So there will be a slight pull-up resistor in here, but I wonder if that's connected over to there. I suppose if I pop the battery out of this, I can check that. So let's probe with continuity. So I'm going to be probing from this pin here to find out which pin it's connected to in the microcontroller. So let's go from there and then just run down. It's connected to this pin, the microcontroller, but is it also connected to this? No, it's not. What is connected? What is this for then? Is it for the power rail perhaps? Is it just a decoupling capacitor? Not sure. I'm not sure what that position's for. I'm just going to pause momentarily and then I'm going to actually draw the schematic for this out and then we'll take a look at it. Okay, a little bit of reverse engineering and testing, which I shall do again so you can see the results. It's very simple, as well as you can see from the schematic. It's tiny, it's just got a chip, a sensor, and that's about it. So we've got the 3-volt supply, which is from a lithium button cell. So that's 3 volts and that's 0 volts. We have the microcontroller, which has a 3-volt supply going to it and the 0-volt rail going to it for power. There was those 2 mystery pads at the bottom there are for a capacitor. It's just across the supply rails. I thought it might have been an option to give them wider variety, but there must be either a pull-up or pull-down, a pull-up resistor in this Hall effect sensor, or it's just programmed onto the pin in the microcontroller. But it turns out that the quiescent current isn't very high. So we've got the microprocessor unit, we have the sensor. The sensor is a Hall effect sensor, and it very simply, it's got the 3 volts, it's got the 0 volts, and then it's got the output goes to the input of the microcontroller just to turn it on. After that, we've got 3 LEDs, with the resistors, which are 27 ohms, and they all go into the microcontroller too, and on their own independent pins, 27 ohms, and wee blinky LEDs. That's fundamentally all there is to it. I'll draw in the capacitor, although it's not actually connected. There's where it would typically be, but it's not there. The quiescent current, if I bring in the meter, and I bring in the unit with the magnet attached so it's in its standby state. Let's bring in the meter here. I've got a 3-volt supply, so I'm going to connect the positive to the positive connection of this, and then I'm going to use one of the meter probes to go onto the negative connection that comes through from the back, the battery contact. So let's connect negative in the meter, and although this is red, it's actually effectively the negative. This is set to the 2 milliamp range, and if I probe onto there, hoping I touch the right bit, let's turn the bench power supply on. Okay, so now if I set this to say, let's actually see what the current of the thing is operating with the magnet off. Oh, what am I doing here? Oh, it's popped off. Right, lead's popped off. Let's try and reattach the lead in a better manner this time. So let's see, let's optimistically set it to the 200 milliamp range and see what its current is roughly when it's flashing. It's not that high. I mean, obviously the meter's just sort of averaging it out for the pulsing, but let's say it's about 12 milliamps. Now if I put the magnet in the back to turn it off, and we set this to the 2 milliamp range, the current consumption in standby state is 0.022 milliamps, which is 22 microamps. That's not bad. That's okay. That's going to give a decent cell life. Just stick these out of the way, and I shall change, as I always say, I'll change the meter lead back to the away from the current position because it's effectively a dead short in those positions. So It comes with these stickers, and I have to say, I'd recommend before you stick them on at all, what I did was to try it in position and to make sure there's enough room, I just used this one with the magnet in the back and just stuck it onto the metal of the door frame, and then guesstimated if there's much room, closed the door gently, and then just to check, slammed the door to see if shattered red plastic came out the bottom, and it didn't, so I did find a couple of spaces. So let me just doodle the sort of spaces I found on a Skoda Fabia, popular vehicle in Europe. My mom's old car. So if you look at the door, I'm just going to try and get this paper around and better, there we go. If you look at the door frame, it's kind of shaped like this. It's got a sort of shape roughly like that, the hole that the door actually goes into. And the door itself, the side profile is this sort of curved metal with the seals on it, and then the sort of like the window section, and then the little ledge section with the speakers and stuff in it that comes down like that. And a couple of places I found, in the door itself, in the edge of the door, there was the lock mechanism, and then down below there was this, I'm not sure what it's there for, but there was a very slight recess, and it was absolutely fine for taking the LED side of it. The magnet would then go in the matching corresponding side of the door. I suppose it would be worth actually shifting the magnet about, just sticking it on without the adhesive pad first, just to make sure that it was turning the LED off, although the door's kind of closed, so you're going to have to just judge that. The other part of the door, the seal came around the outside, and then it had a sort of wider lip down here. And there was a big sort of rubber doink here, which is for slamming the door against. And in the vicinity of that, there was enough space to actually put the magnet, and then the matching, you could put the LED on this side. So when the door was actually open, the LED would effectively be on the side here, projecting out into the sort of path of oncoming vehicles. So looking at the listings on eBay, these typically come in, if you do a search for the keywords, car door warning magnetic induction light, you'll find loads of these listings, and the price varies from quite dramatically high prices down to prices in the region of about $3 a pair or £2 or so a pair. And looking at the pictures, it's clear that, you know, everybody's jumped in the bandwagon for this, because you see some with 5 LEDs, you see some with 3 LEDs at one side and the chip at the other side. But this is just the random one I got from a UK-based outlet. Now, there's one other thing that's worth doing here. If I stick, because this will give you an indication of where they're going to fit in your vehicle, if you were to want something like this. If I stick the pad on here, and then I stick the magnet on, and then I stick one of the little adhesive pads on the magnet, let's try and get this on relatively accurately. The magnet is sliding about on that non-stick coating. And then I bring in the digital calipers. This will give you an indication of just what the total thickness is, and it makes you wonder how on earth does it fit into a door frame, but it does. Let's zero that out, and let's close it in on... Yep. Total thickness is half an inch, pretty much 12.5 millimeters. That's actually quite thick. But as I say, there are voids in, well, most cars, I'm guessing not all cars, that will fit into. So it's quite neat. It also offers, if you're into programming microcontrollers and stuff like that, you could theoretically use this as a base for your own project and just whip off this microcontroller and stick your own on, and then program it to do more interesting effects, the LEDs. I'm not sure are there other applications for this. It's useful for bits like the magnets. It's nicely enough made. Not really much else to say about it. It also comes in a very nice case. I wonder if they all come in a smart little case like this. It's alright, it adds a little touch of class to an otherwise slightly weird product. But there you go, that's what's inside these car warning lights, the ones that fit in the edge of the doors to avoid having your doors smashed off and There's not a lot in them, but they're still interesting nonetheless. I'll have to have another look and see if I can find this 6207 Hall effect sensor. I'm not sure what that is, but it's kind of appealing that, you know, whereas we used to use reed switches, in the past something like this would have had a reed switch, and then it would have had a little transistor as an inverter, or in the case of the microcontroller, it could control the microcontroller directly. But ultimately I think this little solid state component is going to be a lot cheaper than a reed switch, and it's going to be more sensitive. So it makes it quite interesting how things have evolved. It turns out the unit does actually use those individual LED pins for multiple purposes. So it starts off doing this strobing effect, and it does it for about 8 seconds before switching to its sort of triple pulse effect. So that's it doing the triple pulse. And it'll do that for 40 seconds. I'm going to pause momentarily until it does its next effect, which is this slightly disjointed sort of, I'm not sure what effect they were trying to achieve here, but the two upper LEDs seem to be alternating backwards and forwards, but strobing at the same time, and this bottom one is just sort of blinking on and off. It's quite an odd effect, but it does this for 50 seconds, and I'll pause again. And then the final effect, which lasts for another 40 seconds, is this proper stepping through of the 3 LEDs. And after it's done this for that 40 seconds, it will just shut off into a standby mode. So that's quite good. It means if the door doesn't get closed properly, or it means that if it's something goes wrong that goes out of place, the magnet, then it's not going to drain the battery as quickly as if it just flashed all the time. So that's a sensible bit of design. It's quite an interesting little product.